first thing I'm going to do is to change the title of my talk a little bit, because it's interesting. I always wanted to talk about this interplay of interaction, creation, and participation. And I found out this was the official title, but I found out it's easier to order it this way. So we start with interaction, which is probably the most intuitive, jump over to creation, and then go into the most complex, the participation part. And the idea is to kidnap you a little bit. So the first part of the talk will be a grand tour to a lot of interactive exhibits that we did in the last years, just to look at them and see what is interaction, what is creation in all these different examples. So that's the first part. The second part would then focus on one aspect of how can participation work in a way, and then in the third part I show a few examples and I go into a more philosophical pondering about these three nice words. So we are from Imaginary. It's a non-profit organization that started in Oberwolfach. Actually, we are celebrating 15 years this year, and we are all, most of us are mathematicians turned communicators, but still very close to research. And we are very international in a way. We have an office in Berlin, but actually not a lot of people are living in Berlin at the moment, but it's still a very nice place to have an office to go to. And one main focus of our work, not all, is to create exhibits. Exhibits in a very broad way, what it is, but exhibits that can be shown in exhibitions, in schools, in museums, online, offline, but I like the word exhibits in a way, so it's more tools. It's not that much talks or text. And this interactive exhibits is one field that I'm going to focus today. It's just an example, but it's an example where I have a lot of experience. And the idea was to invite you to play along. So this is like whoever has a computer, I don't know if everything works on the phone, but play along. You can either use the small URL here, t1p.de/outreach, or I didn't test it, but it should work also the QR code. You don't have to play along, maybe it distracts you. Some people like to be distracted next to a talk, others don't. That's up to you, but it's also sometimes nice just to play along. If you don't play along now, you can always play along later. The idea is, I'll show you what happens if you open the website. But first, before we start the playing part, I like you to look at these three things, and whenever you see something that we play with, that we interact with, or that we create with, think about, is it a lot of interaction here, or what types of interaction do we have? Is there some creation, and whatever, we'll try to define it later, and is there some participation? Am I part of that in a way? So that's the task for you. While we play, look at these three things and see, okay, no interaction, a lot of interaction, no creation, there's some creation. There are two things that I found out that I wanted to talk about too that don't fit today, but actually they're interlinked. So I put them in red, but just to mention. So the why, or the design ideas behind interaction, creation, participation, that probably would fill a series of talks, but that's, I think, very important, because it's not just what it is, it's also how do you reach it. So that's another talk at one point in the future. And the other point is like the mathematical knowledge transfer, or this kind of curiosity sparking, the concepts behind why we do this, and what does, like on purpose, we put a lot of equations on purpose, we leave the equations for later. There's a lot of thought about the knowledge transfer happening, or the motivation transfer happening, but that's also not, unfortunately, also not, you will see it a little bit probably, but it's not, you won't see our concepts behind it today. That's also another talk for the future. All right, so let's jump, I don't know if you need that, to the list of things. So these are our links. I will go more or less in order and show a few, maybe I will not show all. What's interesting, I grouped them, and that's also something that we started to think about lately in different categories. So the first category, we call them explorables. So these are interactives that you explore a concept by relating certain things, but you will find out maybe the underlying concept, you will, I don't know, change the whole thing, but we call it explorables. And there's a difference, there's also an overlap to games. So in games, you have a certain mission, you try to, I don't know, be good at the game, go to a next level. So there are certain different rules. So there's a whole category of interactive games. And my favorite, which is also the most difficult to do, I call them sandboxes. So this is really where you can imagine where you can create probably more, because I give you a tool. I don't give you the one experiment, I give you also the level editor for the game. I don't give you just a game. No? And there's an overlap between the three, but we'll start with the first one. Here, I'll open a section of things. This is a collaboration with Jürgen Richter-Gebert, a person we work a lot with. It's quite old, little experiments, but I like them. I don't know, I start with a simple one here, which will choose the light beam. So it's an interactive where I have a ray of light that gets reflected. I have circular mirrors, and I can just observe what happens. I can, I don't know, reposition the mirrors. I can put the light inside one of these mirrors, can make it bigger, and I can also try to, I don't know, put a small mirror in there and observe what's going to happen. Small explorable. I jumped to another one just to see a few of them. That's a cellular automata, but it's basically you have these fishes and you have a few rules. So they don't communicate, the fishes, and you can say I can define a number of neighbors. Let's say I have 7 neighbors. Dear fish, swim to your 7 neighbors, or swim with the neighbors if you want, or don't swim with the neighbors. So you can change the rules. So now I swim with the neighbors. I don't swim with the neighbors. I put the neighbors on 0. I put the speed up. And it's very interesting, just by these individual rules, you can easily simulate a certain, you can also, if you click somewhere, they would swim to your mouse. But it's very interesting to just observe how you can generate swarm behavior by manipulating these individual rules and looking at this. Another example.
So the rules are parameters for little field?
The rules are the parameters for each fish follows that rule. So I'm a fish and I say, okay, 5 neighbors, I look at my 5 nearest neighbors and I swim towards the center of the 5 nearest neighbors. That's one rule, for example. And then how fast I swim towards the neighbors. And then the swim with the neighbors is like, do I swim at all or would I just stop? So if I go here, I swim with the neighbors, I stop here, and then I can just observe, okay, here I don't have a neighbor, I would just go around or not.
And the fish sees behind it as well.
Yeah, the fish has like a circle around it and would see what are my nearest neighbors. Yeah.
What are the points?
The points are just obstacles you can put, I think. Yeah. If you click, they will swim towards you. There are a lot of variations. We also have the classical game of life variation, but the fishes are nice. There's a digital version of the double pendulum. It's okay. You can start it. You can stop it. What's interesting, you can just change the length of the pendula. You can add something like a trace here, and you can also change gravity, which is nice in the interaction. You can put a lot of gravity. You can put no gravity here. Put the gravity to the right side. I don't know the flat earthers. What they all right. So another example. Think about creation and interaction. So this is something where I, let's say I choose one of Platonic solids, and then I can start, I don't know, changing here. I shrink the faces, or I cut the edges in a way. No? And then I can say, okay, nice, I like this one. I take the magic wand, and then from that one I start again cutting the edges. And from that one I start cutting the edges again. And I create new polyhedra that I can play with. I can also see what happens if I cut the edges here at the icosahedron, and I get my nice soccer ball, or look at the duality of the polyhedron. It's you can also change the colors, transparency, and play with them. All right, so that's one first section of explorables. Now let's add a little bit of a different sense. So that's an explorable that uses sound. You can imagine there has to be some interaction, so I can just change the position of the cannon. I can also change the
Can you add more edges there?
Sorry, more?
Could you add more edges?
Yeah, you could add more edges. Not in this version, but there is also the editable version where you can add more edges and put them in a runner. The thing is, like, each of these bouncing edges has a certain sequence of tones. And it's called Bachel ball, so it's the Bachel bell canon. That's why it also would sound. It's not completely random.
But, so the balls, they don't follow the rules of physics, right?
They somehow follow the balls of the rules of physics. As they could do in a simple simulation.
Because some balls do crazy things.
But it's like they should more or less follow. But it's, for example, if you put it very, I don't know, sometimes they go through the wall. But it should.
I think different edges have different elasticity.
That could be the case too. Yeah. That some are more less bouncing and more bouncing.
Can you ask more questions so that we stay at this for a while?
Sorry, just turn off the sound.
So how does the note change? You have to touch it some amount of times,
There's
yes?
a sequence of notes from the canon, and each, like, for, I don't know, the upper one has like ACE, and then it would always, the first, like the next ball would be E, the next ball would be C, the next ball would be E. That's also something that you can change. That's an arbitrary thing that it would give you at the end also something like a canon. But again, I'm not, like, this is an example we put out for Christmas. This was like a Christmas game, but there's, usually these exhibits also, they have like that's the whole section, the knowledge transfer section, I'm not going into it, but they have an explanation, right? What can you talk about it? So if it's an exhibition, you have an explainer, and then they can start going into what is a canon, or I don't know if you want what is physics, simple, or, but it has a very, it's playful, you know, but it's not a game, you know, it's like, that's why it's like an explorable, there's no mission, you know? Maybe the mission to sound nice, but it's, you just play.
I mean, is it to think about missions that one could have, right? Like,
think about missions, exactly. Yeah. And that's why it's interesting how you can turn an explorer into a game, or the other way around.
or a sandbox. So yeah, I see.
I show you another one which is very playful. So this is like a real-time simulation of fluids. So it's on the GPU calculating Navier-Stokes equations for you, and you can just play with liquids. There's a version where you can also change the dispersity parameter, a lot of parameters that you have in these liquids, and it's part of a mini museum where we also have the equations next to it and we explain, but here it's like a meditative, I play with liquids. And I know that there's a lot of real-time mathematics solving this behind on using the GPU, because otherwise it would not be fast enough. It's nice. All right, explorables. Let's jump to some games. We talked at the breakfast. Oh, that's the wrong link. I know it's not the wrong link. On puzzle sliding games. So there's a lot of very known puzzle sliding games. So this one, there's also like a commercial product out of it. It's an old Japanese game, but it's very nice with the cars. So the red one has to go out here. Okay, what do I do? So this one has to go down. In order for this one to go down, I have to move these ones up. I try to solve it quickly. That's the simple level. Huh? Like, that one goes out. Yeah. Next level. So, okay. And then you go to the next levels, and it's getting quite complex. But it's always, it works very well for kids, because it's, you can turn it from, like, there's a lot of skills automatically. You would solve it from the back, from the front. You would see, okay, this car has to be at that end position. How do I get that one? And it's clearly a game. So.
Just a bit of there a question?
Yeah.
Do you have for example, in this kind? I'm going to ask about this one, but in general, like something like minimum number of movements,
Yeah.
and then that the user gets to find it, or
Yeah. We have we have a whole. I'll show you. The idea is to do a general 2D sliding puzzle engine. So we can just change the rules, and we have the engine, and the engine would calculate the puzzles, because that's also always tricky. It's super tricky question, like the difficulty levels of the puzzles.
yeah.
But puzzle generation is very important. And then you have all this thing, what is the shortest path? Is it solvable? What is the shortest path? All that kind of thing you could solve in a general level, and we didn't get the funding for this yet, but this was something that we really wanted to do, this kind of a more general puzzle creator. There is a website, I don't know it by heart, which has all huge collections, I don't know, 5,000 of these 2D puzzle sliding games, which are very different. I'll show you another one here that I like a lot. It's maybe less known. We call it Space Rescue. Of course, you give it also design. You can also just play it with but that's a very nice one. So here, the astronaut has to fly to the spaceship, and she can only move to the end. Like she would only stop.
Ricochet Robot is here.
Sorry.
Ricochet Robot, Alex Randolph.
Ah, you know that. Okay.
The game is here. We can play it.
Okay, perfect. Fine. And then I don't have to explain. But and it gets like, I really like the way how it tricks your mind. If you go to a higher level, it's kind of what the hell do I do? So it's really interesting. But at the end, it's the same. It's a 2D sliding puzzle game. Here we already have a kind of random level selection, so it's not always the same levels. We generated many more levels. And yeah, it's interesting to play. Nice to play. Nice to solve. I got like this kind of games where you want to go to solve the latest level, and it took me a couple of hours.
There's another question. In this part of reflecting about how we are deciding to grade from easy to hard, is there anything written of why the person who made it decided, okay, this is how I'm gonna label it, or this is the measure of complexity?
It's interesting because usually maybe for the car thing, it's easier to see. I mean, you have something like the number of movements, but that's not always a difficulty. You know, how many cars?
No.
Here, my feeling was like the number of, how would you call it, arrangement sets, because sometimes you have to move the red ones to one position, do a lot of moves, move the red one back, do a lot of moves, move the red one there, do some moves, at least twice, and that makes it much more complex. It's not just the red one stays.
Yes.
So, I don't know. There's some theory. I spoke to a person in German who is an expert on that kind of judging difficulty, but of course you also need to conceptualize this. I don't know if you can directly derive it from the rules. No? That would be interesting.
Maybe I can add one idea that Hugo Parlier told me, who will be here on Thursday, I think. And the idea was this kind of puzzles. Sometimes you have one solution, and you have to follow some concrete path to add the solution. And some other puzzles, I think with cars, sometimes that can be the case. You can do kind of random search, replace cars randomly, and have many solutions just by kind of wandering around.
Yeah.
And this is easier to solve because people wander around and then, actually I can move the red car. And this is the way you can study the graph of solutions and do this, kind of see if I have one solution or I can wander around and find a different solutions.
I mean, it has also this kind of psychology level of this, you know, against my intuition, you know, and sometimes it's maybe a very easy solution, but it's against my intuition, you know, and so I don't know if there's this very nice computer game, Baba Is You. I don't know if you know that one. It's really Baba Is You. I have it here. It's not a math game, but it's so cool, and it tricks with your intuition all the time, and sometimes it's so difficult, and then you know how it works, and then it's like tell me. It's really nice. It's a game where you change the rules all the time. So it allows you to change the rules all the time, and that's something that you're not used to. You know? If I can change the rule, not only the game, but I can change the rules of the game. That's cool.
So one idea could be that we're trying to implement is to have a virtual machine that is recording how we humans are playing, and then on that deciding if there is a measure of complexity that we can, with machine learning, learn, and then adapt and try to categorize something like that.
I mean, you see this kind of levels and difficulty, that's part of games. Here we have another game, so we can choose the level of difficulty. We start with easy, number of polytopes 4. So it's called Match the Net, that's all you need to know. Match the Net. That one is easy, let me see if it's really easy. Yeah, I think it's easy. This one, does this have a blue one? Oh yeah, 2 blue ones, okay. I guess it's like this, submit. Yes, I get 4 points. It also shows, now I forgot to show you, it also shows you that it's really this way. I'll solve another one. So it looks like this. If you click on solution, it would fold them for you, so you can see, okay, it's really that one, and then can go to the next level. You would say, okay, but that's easy. We can also go to difficulty level higher, if you want. And you can look at them and see, okay, you have to look at it, and you get more points in the higher difficulty, if you do it right. But they're tricking you because they all have this kind of. I will have a count.
Should you have the names of the solids?
There are many who have the names, but some of them are also automatic, like randomly generated.
Or at least the category.
This one, I guess.
And they are converts, right?
Yeah, they're converted.
Yes.
A nomenclature for them.
So here it's also a game, and the idea is to maybe you saw this medium level. There's time running here, and there's also points. You have five tries. The higher the level, the more points you get. What's the maximum score? So yeah, so the level and the score, and yeah, it's interesting. It's also,
Andreas, is this part of the Math to Touch, or this is separate?
No, it's a separate thing. It's a collaboration with Technical University Berlin, who are experts in polyhedra, so they have the biggest polyhedra database, and they can just generate polyhedra and do all that. So it's not part of the Math to Touch. But
then you don't have topology, like interesting topology on these ones.
yeah, there's also a lot. We have one version. They also work with the whatever Johnson solids, and they show you a little bit of mathematics behind it, and it's not just for playing the game, but also some I don't know, the classical polytopes. All right, so that's a game. There's one game that we recently did. I really like it a lot. We put in an exhibition like an arcade machine. So we developed this game in 80s Atari style, and you play it with joystick and a button. It's also multiplayer. I'll show you the one-player version first. I have a boat, I have time, and I can go left and right, and I can lower a probe to the bottom of the sea. And the idea is to find the treasure that is on the lowest part of the sea. And I have 10, okay, this is a version where I have not only 10 trials, but you can also limit the trials. And then you can see that you get feedback on the scope, on the gradient, on that position, and then you can try to find the treasure. Let me see if it's here. No, it must be somewhere else. Let's see. Here. Yeah. The curve is always automatically generated. Sometimes it's more tricky, sometimes less tricky. And the idea is to minimize an error function. The idea is to learn how to minimize an error function by going with your gradient down. So it's like, by playing, it's interesting here, you play and actually you do gradient descent without knowing it by just playing, and it works very well also with kids. What's interesting, you also have multiplayer game. So you can also add a computer player. So here it's like 2 against the computer. That's a computer that plays just a normal gradient descent where it would, well, sometimes be fast. It's also depending where you start. So, but you can also add a random player and compare. And what I like here is that you, again, you're not talking about knowledge transfer or the mathematics part, but here I like that you play the algorithm. I don't tell you the algorithm, you just play it, and afterwards I ask you, what's your strategy to find the treasure? And I say, if it's like this, I go down like this. If it's like this, if it's flat, and the children or everybody would also tell you, if I tell them, can you draw a curve for me? That's another, you draw the curve and I play treasure hunt on that. And they would give you all the crazy curves and the flat ones, and so they also understand the issues involved in finding global minima. So that's a game. Here's a game which is a bit more abstract, but I think it's also explaining a concept very well. So the idea is you have all these cards, and you can open a card. The card gives you a number. You have 10 tries, and you can And the idea is to have the highest sum in your 10 tribes. So the numbers are summed up, and you can only open 10 and you can repeat. That's the good thing. So you can also repeat. And now the question is, how would you play? So now I have 6 turns left. Would I open a new one, or would I go with the maximum one?
The range of numbers is between.
You don't know. It's always different.
Can you unflip the negative number?
Well,
They cannot unflip. You can just repeat. You can open a new one or repeat a current.
Oh, you can repeat a card. Okay.
Yeah. So now I have 5 left. Should I open a new? Let's try one more. Okay. Now I stay with it. Okay. And now comes the interesting part, and that's the concept behind. How often do I open a new one, and at what point in my 10 games do I stick with the highest one? And it's very interesting. Here we do just like a Monte Carlo search, but it's like 4 times you open a new one and then you stay with the highest. And this is quite independent from the numbers here. The maximum could even very high, or it could be -1, or how they distribute, they're always different. So sometimes they go up very high, we have complex random, but it's always different, but still the idea is find a strategy that works. And the strategy generally is like 4 times and then stay with the highest.
I guess it's incomplete in the sense of the game theory incompleteness. So I must know which are the goals of my opponents. If my goal is I want absolutely to become first in the whole group here, then I will always go further to hope to find 1 million. If my goal is that, okay, I'm second and it's okay, I want to stabilize my position. So without that, you cannot have an algorithm.
Yeah, but the goal here is like find a strategy that works for. I give you 1 million issues, 1 million problems with all different numbers, and you find the good way. And here the good way is like 4. I open 4 and then I stick with the highest.
Playing solo.
Playing solo. Yeah. Maybe you can also have it's interesting because if you play with other people, would I give them the same numbers? Would I give them different numbers? This whole in this whole AI field, it's always very interesting because you work in these uncertainties. You know, it's like uncertain. You don't even know what's the range. You don't know anything, and you have to discover. You have to explore, and that's the funny. That's also a core concept, I would say, in all AI learning, because I have to explore if I don't know anything. But at one point, I have to exploit, and and exploit means I stick to the best knowledge I have so far, but. Maybe I still have to explore further because the environment could even change later, and this game it works quite well. We have a version with restaurants where you can go to restaurants to eat instead of flipping cards, but then people would always go to the sushi because they like sushi or to pizza, and it distracts them a bit. So now we use it with the numbers, and it's interesting to discuss also the concept.
But in that game, when they choose. And values, do they have at the end feedback to figure out what they could have chosen better? Can they see the other numbers to have a feedback or not?
They have here, like the final result 363, 20% worse than the average best strategy. They give you some feedback, but it's not. The feedback is also very relative because the numbers are always different.
No, but do they have a way to figure out at the end to see all the numbers to see?
Yeah, they have one version where you can see all the numbers, where you can edit the numbers too. That's also interesting. So you can put 1 million in one card and -1 million in all the other cards and still play the same game. Reshuffle the cards.
So one question there is it possible to change the number of cards that you get so that to see how it's depending on the number of cards that you have?
Yeah, that's something we never really. Probably you can already understand it. Now we have, I don't know, 21 cards and 10 turns. But the number, of course, the relation between the number of cards and the turns is very important. No? And but here again, it's like I can show you. I don't know if you have enough time. I can show you the version where you can change the numbers. That's super interesting also. And then you can also do this, like play. Let's say we take the same numbers, we reshuffle them, and you play again. That's different because then I know what's the maximum. Maybe then I do some more exploration. But the AI field, I think there are several core concepts, like the whole data, whatever training thing. I'm going to show this later. But this kind of working in uncertainty and this stochastic environment. And that's a concept which is not normal in a way. So you have to. I have one strategy that works in many places, but so I fix the strategy and the environment changes. It's different. It's not the environment is fixed and I change the strategy.
Andreas, I have a general question. I think it could be very interesting to study how all of you have many games.
Yeah.
Like, what is the most addictive of your games? In the sense that, like, for me personally, I think this game is not addictive, but
Yeah.
it's very personal.
Yeah.
It's a very interesting outreach question. Like, you give games to people. What is the average time, average number of times that one person plays a game?
I mean,
Do you have this data?
yeah, I can. We have a little bit of data. The games for me is like also, again, what is the knowledge transfer behind it? So games which are simple but have this kind of like the car game. That's a game that people like a lot. We once did a version of this 2048, maybe you know that game, where we added some algebraic surfaces as images, but the game stays the same, and that's super addictive. Super addictive. It's also interesting that you could also probably do a gender analysis that a lot of women play 2048. I don't know why, even if it's not independent from the graphics, would be cool to know. I'm not into that much into evaluation. It's more like what we know from the use in our exhibitions or in our workshops. It's also interesting also the design question again. That's the other talk. For example, the version. Maybe I'll show it to you. When you have time, I show you the version with the restaurants. I think if you do it with the restaurants, it works better. For younger children, because it's kind of more clear. I just have to find it here. So that's the restaurant version, where you choose a restaurant, and there's like here it's less. We have 7. So the idea was you have 1 week in the city you don't know, in Les Diablerets, there are that many restaurants, and try to eat well on average over the whole week. So you choose a restaurant, you go here to the burger place, and it's 0 stars. You go to the fish place, 3 stars. But here, the first version, that's also introducing the concept a bit, it's like that 5 is maximum. So of course you try to find the 5 one maybe, or maybe not, and then you stick to the good one. But if you go to the next level here, it's like you don't know the maximum. So it gives you 1 star, but you could also have one with even more 4 stars or even more stars. And here you can also see, you can open up the stars and you can also edit them. So I can say, okay, I make here like a 4,000 stars restaurant, and then I can, I don't know, reshuffle them, and now I play the game here. And just changing the design. I mean, this is again the more abstract one, but it's more amigable, friendly to young children, for example. That's also maybe later we'll put some comments in terms of how do we reach the non-scientifically inclined people through design or through other formats. Okay, do I have one more game? Let me see. No, I think that's fine with the games. Let's jump to sandboxes. So now, I'm not sure if I'll show one of our very first. Maybe that's also the exhibit that made Imaginary start, and I think it's still an exhibit which is super nice because it combines a lot of mathematics and it's very, I don't know, creative interactive. So the idea is just simple. I give you a real-time ray tracer of algebraic surfaces. That's the idea. So you just play here. You can also, if you want, you can just add a parameter, and then I just play around. I can move the parameter, and I can more or less in real time. I can change the colors if I want, and I can play with it. I also have a zoom level, so I can go further out. The surfaces I cut with a sphere. That's important to know. So that's why they look round. You could also cut them with a square, like a cube if you want, but it's and then we have like a big gallery of, I don't know, you can start with simple things, like, I don't know, I have a sphere, and then what happens if I don't know, make here a 3, and then I make a 4, and a 5, and a 6, what happens? I make it all 8s, for example. So you can play with already given, okay, now here you see it's cut with a sphere, right? It's actually like this. But you can also say, okay, what happens if I just take the whole thing and add another surface by multiplying it? So I add another one here, or I add another one, whatever, and you play around, and then I give you the tool. So it's really, that's why I like it, sandbox in a way, because it allows you a lot of playing around, and also I would say also very interesting. I mean, there are a lot of, you can imagine what happens here, because usually you go from the equation side, and then you see what would the equation look like, but you can also do it inverse and say, okay, I would like to have a whatever image. How do I create it? And that's, of course, extremely complicated, but that's super motivating for students to say, okay, I want to have my Mickey Mouse. Okay, then you have to multiply the spheres and move them. Here you can move spheres, but that's in a way simple, so it's just 2 spheres, and one sphere has a parameter here in the x direction that I can move. But now the question, what happens if I add a small parameter? Let's say I make a minus, let's say I make a plus b. So now I have the b here, it's 0. What happens if I make b higher? You see, the spheres get kind of separated from each other. What happens if I make here instead of plus and make it a minus? They get merged, they smooth into it like this. So now you can already build, I can make a snowman very easily. I make it white, I put another sphere on top, I make it a carrot nose, but I have to place it in the right way. And that's also very interesting, this kind of playing. At the end, it's just the zero set of an algebraic equation, what you see, but it's nice images. I'll show later as an example also how such sandboxes would motivate creation or participation. There's an online version we did that you can also try. Probably this, I don't know if it runs on the mobile phone, but it's the same here. We did it for the New York Times once. They wanted to have it for Valentine's Day. They wanted to have some mathematics. That was nice. So we had this heart here. I think there's also, let me see, something nice if at the end you change the cube to a square. You have this famous slip of the heart. So that's very funny. So the heart gets a real slip. You could analyze why, but it's pretty cool. And you can play with it. So here it's interesting also the whole technology behind this super fast ray tracing. It's not at all trivial, you can imagine, because you have to compute in very fast the solution set of a higher dimensional polynomial. But nowadays you have the GPU, the graphic cards, and you do all the calculations in parallel on the graphic cards, and that's the good thing, that now web browsers got very powerful in the last couple of years. So we can do everything in the browser now. There's still errors. There's no visualization tool that can do it without errors. Like if you have a singular line, for example, you would not catch it with your ray tracing tool, but it's interesting, and that's why we usually all the tools I showed you, they all run in the web, because we are more and more moving to use the web browser as our development tool. Everything is openly licensed, what we do. I'll talk about this later. So, and that's just easy to deploy software this way. You don't have to.
Technical question, but you have a virtual machine that is doing all the computations.
There's a shader like on the that computes the intersection of the ray and the surface.
Yeah. And then you send it to the
and
website.
Then I send it, yeah.
So you actually have like a station where you have a virtual machine doing everything.
But it's in the browser. It's the shell of the browser. Yeah. But it's separated. So you have the user interface, and then
and then you're communicating with a server.
Yeah.
Okay.
And it's also, if you want to use that machine, it's also on GitHub separated.
Mm-hmm.
Okay, so that's a sandbox. I show you another sandbox again using sound. I don't know if it's a sandbox, but I like it a lot. So it's a tool where you here it's an exhibit. So the idea is it's a cut through your vocal tract or through your head. So you can imagine this is like I'll start making noise. So this is the lip. You see here you have the mouth. You can close it. Here this is like the throat here, and then I can more pressure or less pressure, and then I can try to talk. And you can now really try to talk. So the exhibition is called La La Lab. So I'll try to So that is a bit more difficult, but but it's like a simulation of, and you can talk. Yeah?
So
But
you can give your talk using this.
I found like somebody that, like in the exhibition, we give you this mission, try to say la la la, that's easy, but there's one YouTube video where you have this Donald Duck talking with this tool, it's called pink trombone. So it's like the trombone, but it's the pink trombone, like the voice trombone. And of course, there's a lot, it's also a real-time like solver of a differential equation that puts here the voice through this kind of cylinders in different size. And so there's a lot of mathematics behind it that we show in a way next to it, but here you play around. And it's a lot of fun. It also works with touch screens where then you can control, like sometimes you need 2 fingers also like to with your tongue. It's simple. It's also 2-dimensional, of course. In reality, it's more complex, but it's you can also connect here the nose. There's one thing I meant to mention is also like humor. This is funny, and that's also very good in communication. If you manage something that is humorous, difficult, for people who don't have the humor inbuilt. It's difficult, but this is like it's just fun, You want to try it, so it's like cool. Let me try. I'm not sure if I want to call this a sandbox, but the idea is to make it more like a sandbox. So again, coming back to AI. So this is an exhibit where you play with a trained network. So I have an input here, and the network would try to find what I'm painting. So here, I don't know. I can also paint further and say, okay. No, I tricked it. And it's also, of course, to find out the flaws of that thing. But the sandbox part would be that I can train the network myself. So here I have a network which is not trained, it's just randomly initialized, and I can see it doesn't work. So the predictions are just small and not good, and I can just feed in here training data. And a further step, we also would allow the user to make their own training data. So you can also change the training data. Here it's like it's not that easy because sometimes you need a lot of training data in different ones, but still, that would be nice. So you can also train it not only for letters, for numbers, but for letters. Now I trained it, and I can see if it, already kind of much better working.
Sorry, can you say again, what is a sandbox?
A sandbox for me is like an interactive tool that allows for like creating a lot of things. That's why it's called sandbox. Imagine like a real sandbox where kids go. I give you just a sand and you create. I make a castle, I make a tunnel system, I add water, and that's probably why it's called sandbox. And I'm still, I played. My grandmother at one point she kicked out the sandbox of her garden because the neighbors were talking bad because her 18-year-old grandchild was still playing in the sandbox, which was me. So she took it away because she felt ashamed that you're not allowed to play in the sandbox if you're 18 years old. But I still think it's it's an amazing pedagogical tool to have this kind of just pure sandbox. You give the kids a sandbox and they create and they play and then they learn a lot of things just by giving them a real tool. I mean, this is, of course, these are tools which have certain restrictions. So here you have to work with a neural network that's already predefined. Of course, we can open. There's another version where you can add hidden units and change the neural network. Here we also give you, but it becomes complicated. But you can change the architecture of the network and certain parameters and whatever optimizer. But that's difficult for people who are not already a bit familiar with this kind of. With the theory behind or the mathematics behind.
And one question is there like a progression with respect to the sandbox, like for example starting with 2 numbers and then understanding why is the depicted like that, and then 3, and then I don't know, like a progression that could help to train oneself.
You mean if you show a sandbox that you first show a simple example, then you show a complex example, and at the end I give you the sandbox. Yes. That's a classical way that, I don't know if you know the Evolution of Trust by Nicky Case, which is an amazing tool. So they also introduce you to the whole concept stepwise, and at the end they give you the full sandbox. the problem is we usually work in exhibitions. Exhibitions are very different because people don't have a lot of time and they don't want to click through progress of 1, 2, 3, 4. I give you a sandbox right away, or I don't give you the sandbox. And I just give you a simple version because I have to catch you quickly, and then you might stay for 10 minutes or 15 minutes depending on how many other exhibits are around, but it's not, it's different if you do a workshop or if you're alone at home sitting on a website and I can spend an hour. Evolution of Trust, I open it and then 1 hour later I landed at the sandbox. So that's, you usually would not, maybe, but not necessarily at an exhibition. There's this also tool where we have one version, but I would also more consider it as a sandbox because it's like a drawing program. So here you draw with the symmetry groups of the Euclidean plane, and you can change the symmetry group. So here the simple one where you just translate. So I draw something, can change the color. I have certain drawing functions. I can also. And then what's interesting, I can change the symmetry group and see how it's connected. This is part of a very large here Jürgen who has an amazing iPhone app and a lot of iPad app and works a lot in this symmetry groups also in different geometries, not just the Euclidean one. But again, here you draw and you play around, and you can also observe the features of the different symmetries, and it's interesting how most of it would automatically look nice. Okay, I'll show you one. Let me see. A very recent one. So I will later go a little bit more into detail about Surfer and what happened with it. Now we just started last year an exhibit where that's the video. I don't want to show you the video now. I show you the digital version, which is not the exhibit itself. So here again, we talk about user-facing design. It's also interesting that Aurélien, we used Lego here too. But just like the sandbox itself, the idea is it's about mobility. So it's a simulation of the future of mobility, and you can draw a city here. So the inspiration was, of course, the old game SimCity. You have different, you can draw parks, industrial areas, like larger housing complexes or smaller houses, and also water areas. And then I put some industry somewhere. So, and then here you have the citizens complaining. They say we need more places where we have to go work. We need more industry, whatever, but we don't have enough green space. Okay, I give you more green space. So you have a little bit of feedback in order to make them happy. You can also see how the pollution level would be here. So there's a lot of pollution around the industry. I can lower pollution a bit if I put some parks here, then it would be less. I can also look at the noise level. Of course, here they would be loud. They would be loud, and then it becomes very interesting because the idea is to make them happy, of course. And it's interesting with the whole mobility because they also they need the streets. They have to move. And there's a quite complex parameter how I can judge what is good mobility in a city, because people have to move from. They have to move from the house to the workplace or to the shopping place and so on. And here the idea is, and that's why we interfere into the future of mobility, that it can add, I don't know, autonomous vehicles or electrical vehicle, or I can add concepts like, let's say, this dense city where suddenly the shopping places would merge with the housings, and then they don't have to go that far. And that you see here now, it makes them happy. They still have too much traffic here, so I probably need more streets. And so on.
Andreas, can they walk in this play?
They can also walk. There's also an activity which is called Walkable Cities, and it gives them bicycles and walking path.
Okay, good.
For the calculation of the mobility, they can also walk through the. The problem is with shopping. That's also another thing, because if they have to shop, walking with carrying the bags is a bit hard. It's a simplified simulation. All right, I think I'll keep that here. And jump back to the second part. So let's try to define. I don't know if you have time to look at interaction, but I try to, not a proper definition, but interaction. It's very intuitive. So in a way, it's just interaction. I think we understand what it is between the people and the machines, or the people and the computer, or the people and the exhibit. I find it also very interesting that it's also the interaction between the people. So we have one exhibit which it doesn't do much, but it stimulates a lot of discussions. So it's very interactive. People would always talk. The exhibit is not, you cannot do almost nothing, but when you look at it, you would always talk to, because you're kind of what? And then you start talking. So that's also an interaction. But, so I think this is clear. I put here, I think it's good if the interaction is connected to the mathematical content or the message of the exhibit. It's not that obvious, but I was at a science center in India once, and they had a new exhibition on nuclear power. It was very interesting, and they were super proud about their most interactive exhibit. They showed it to me. They said, look at this exhibit. It was a display, a computer, like a screen, and then below it had 28 buttons. And look at this. You can choose the language. And this was the interaction. So you chose one of the 28 languages they used for this exhibit, and you could interact with the exhibit by choosing the language. It's a type of interaction. It's also nice in the linguistic way, and you see how that translates to probably different scripts, but it's not relevant to the content of the exhibition. And I think it's very good if you look at this interaction. Sometimes it's, of course, I changed something, but it's not really influencing how the message is transmitted. And then, so I would say that let's look at interaction that's relevant, not just because it's there, and sometimes you need it that because it's fun, but it should relate to what you want to transmit. In terms of creation, that's interesting. So where does the creation start? Interaction is okay. I do something, but am I creative? So in a way, like creation is where you identify with what you did. You're proud. You did something. And say, look, that's the city I built. Or can you see this? I did something. I even sometimes have this kind of again, the good thing is that if the visitors or the users of the exhibition can create something that surprises the authors of the exhibit. And that's, if you put this as let's do exhibits this way, so it's not kind of X, doesn't matter, or N high number of options. No, it allows for surprise. It allows for, wow. I mean, with Surfer, I will show you some examples. What visitors did in terms of algebraic surface, it was like, wow, cool. What, how can you do this? And but again, there's an overlap. So in a way, I interact with the fish swarm, but it's not really surprising probably the author. But in a way, I'm still proud of my fish swarm. I'm still proud. So this kind of identification is important because it adds your personality to the exhibit. I'm quickly talking about two other formats which are not the interactive exhibits, but now we're jumping slowly to the participation part. So I'll show you, let me see, a format which is by definition in a way participative. We'll see if it's really participative, but is competitions or challenges, we call them sometimes. So we also run the International Day of Mathematics project together with the IMU and many partners. And we design this, we call them challenges every year. It's not so easy to define such a challenge. It's also very important to see what languages are used. So usually it's kind of, so this is a photo challenge. We give you some instructions, we give you some samples, and the idea is, so there are the rules, and then you can maybe also some further whatever tips, and then let me see where's the results. And then people create. So it's not an exhibit, but then they would create. I'll show you the creations we got. So here we received I don't know, about 3,000 images all over the world. People creating, following that that challenge. So here it was all about.
Can you say what the rules are? Sorry, can you say what the rules are?
The rules were create a picture that shows mathematical concepts. I'll show you mathematical concepts, but you're not allowed to put text. There has to be you in the picture. That's important. That's why it's always a human there. I have to go back to the rules. Let me see. There are the rules. So take a picture of yourself with a mathematical thing. Something you drew, you did, and in the results we then classify them a bit. So it's like this. They did And that's also interesting because automatically people around the world they came up with, I don't know, kind of creating with human people some figures, but it's also, I don't hear more the landscape part. It's not always the human in there, but it's still interesting. And just as a format, it's sometimes I feel bad doing a competition because you just define the rules and all the others work for free. It feels strange, but a lot of people like being part of it. So now we slowly go into this participation, and they create, and they create, and then they show it, and they are part of the game. They are the game. They are the results. Then we just define the rules, and you can't imagine how proud all these people were. This is like one of the most visited websites of the IDM because, of course, they share it, and my picture is there, and can I show it to you? And whole school classes were working with it, and it's really, it's like they become the project in a way. And we did this for now, like for 3 times. Now we are just thinking about the 4th competition. The last one, the one before, was about a poster. So here the idea was to draw something. So we gave some examples, and there without words. It can be mathematics, but it's not allowed to have a word on it. And the results were also amazing. A lot of really, really nice
How
posters.
many entries did you get for both of those contests?
The other one was about 3,000. Here we got, I think, 800.
So for 3,000, how did you choose? Or did you just put them all up?
The ideas we don't have, like we put all up who are okay with the rules, more or less okay with the rules, because sometimes they just put a picture which is not their own. But we had to screen them all, and we have now we develop tools to also to handle because the problem is it's super international. So people and for example for the other one we also wanted to have a map where we show where the pictures come from, but just a question like put your country. The problem is with IMU you're not allowed to mention certain countries like Taiwan. I'm filmed here, but it's like this, So you cannot have a list of countries. So you're people put the countries, but then you have I don't know how many ways of putting Turkey just in Turkey here, Turkey. Then they put it in their own languages, in Arabic letters, whatever. So we built a lot of tools to do this quite quickly.
Nice, very nice.
So competition is a nice format, and I don't know if I have another format. Yeah, I wanted to. No, I skipped that. I'll jump quickly to the. I don't have time. Participation. So, and I think this is for me the most beautiful concept because it's people become part of it, or even better, they take over it. But how can we enable this? How can we make them motivate them enough that they just take over? And here we also see the problem because a lot of people don't want to be taken over. I'm happy being taken over because that's at the end how it should be. And I will very quickly run through one of our core concepts, which I think is one key ingredient. I don't know if it's the only one of allowing participation. And it started in the very first exhibition we did in 2007. That people went there and said, "Can I copy these images? Can I show them in the school?" And we said, "Yes, yeah, why not?" We're talking about 2007. Creative Commons was just invented or not really known yet, and we started then at one point saying, "Okay, let's open license all the content," and people starting to copy. This was the first external organized exhibition where I didn't do anything. They did the whole exhibition in Kiev, in Ukraine, using all our content and adding own content. And in a way, we invented this kind of open source exhibition, open source mathematics exhibition, open source science exhibition, not open source software, but we give you everything. And here it's also interesting. We give you not just the images, we give you everything we have, all the concepts, funding proposals, designs, text, all you need, all our experience that we have, just to that you can copy it, and that you can also, and that's the automatic process. If once people start to copy, they will always enhance it. And usually for the better, and always, they translate it, they add some local flavor, new images, new exhibits, and that's really cool in a way to make them participate. I will jump over all these. So this is about the different formats of content that can be copied, but we don't have enough time. So we have 4 of these exhibitions that can be copied. So that's, for example, one on mathematics and music. It's 23 exhibits that can be fully copied, and they are copied. So they're copied several hundred times in many countries. And the interesting thing is that sometimes they even, like here in Uruguay, for example, they do their own, a lot of own content, their own concept, that toured the whole country with exhibits based on that open concept. And it's also interesting talking about people that you don't reach or regions that you don't reach. That's also interesting in terms of science communication. We're also very much stuck always in our Western world, but at least we have science museums in major cities, but in many countries there's no single science museum. It's just starting. And in a way, we managed, or the content itself managed to get spread to many, many places that usually don't have science and the public out there. Okay, I'll skip that, and I'll just jump back to the core thing, this kind of, let's open everything in a very, very full way and say, okay, if I open everything in the terms of license, I open my door for participation. And of course, I break the classical hierarchy because if I open up everything and I want them to take over and want them to reuse the content in their own way, I give up control. But so the classical way, and I think most of us are still doing it, and it's not that bad. But so we have the creator. Maybe there are two of one museum, or one organization. Maybe they partner up and they create the super science activity, exhibit, whatever, and then you have the users interacting. And most of the time it's like this, and it's like, I'm on top, I'm cool, I can do it, and you enjoy. And it's not per se bad. Sometimes there's more or less interaction, but I would propose and say, okay, no, it's not this way. There's not this one expert there. It's like they can create exhibits, they can put it in a museum. You can be a visitor, you can look at what they did. So, and in a way, we work like this in Imagine. It's like whenever there's an idea, we say yes, and let's kind of allow for all these kind of ideas that come in, and there are other concepts. I think one concept is also this kind of having things not super professional. It's very interesting. Because if it's super professional, it's closed. If you leave that kind of things, you're different people, but you ask question right away. Can I change the game? Can I do this? And that's the way it should be. You make the things maybe on purpose or not on purpose, but they kind of leave the door a bit open for change, and then people have the idea and they change it. Okay, I'll jump over maybe just for the surfer, I want to show you that the participation went super crazy. People created images like this. I show you also the equation, which you can't. But I put the equation also in the document. You can try to put it. You will see that the actual surface would continue. It's just one part in the center. It's very interesting. But people created a lot of images. But we also did talking about participative exhibition. So this is an exhibition which started with an empty wall and a printer, and the visitors created the exhibition. So they kind of, but I would still say this is creation. It's not that much participation because or here they created, I don't know, like a Michelin, like a chef did some algebraic surfaces food. There was a super professional fashion show based on the algebraic surfaces. So a lot of things happen then if you allow it to be. I think I'll skip that whole project, which is a pity because it's very nice. So this is actually the actual exhibit. So I showed you the digital simulator, but this is like you build everything with Lego, and then it gets alive. I think also talking about formats to reach different people. So here, for the first time, we did a board game for the city building, and that's also the format is very interesting. I think text or talk is not where you reach the general audience. Make it more like a game, make it a Netflix series, whatever. The different people have different input media, and I think we just have to jump over and let the young audience also. That's why the participation is important, because then they would take the content and put it on TikTok, which I will not do. But that's what's needed. All right, so I'll jump over this and just wanted to look at the definition of participation. Just check. I try to define that too. Let me see. Okay, here, but I still got it. So the idea was to say, no, but that's still creation. No, anyway, I'm lost. I jumped to the end. So just to show you here, in terms of, so the explorers in the games, they were kind of interactive. The sandbox and the tools, I would say they're creative. And the real participation, that's still a question mark, but I would say, if you make it open and let the people be on your level of decision power in your activity, then they can participate. Very often you have participation when you start creating, but it's with a limited number. And people, usually they create and then it's done. And that's maybe also our philosophy, that no project is ever done, and if you allow it for dynamic change later, you have to participation at a later point. And this is something that would not only work for interactive software exhibits, it would work for all types of formats, and maybe it's also interesting to think. I was thinking today, a talk has actually no interaction, I think. The Q&A of a talk, there has a certain interaction for the people who ask, not the others, they're just listening. A workshop, if you do it the right way, has a creation part. Now you can think what would be the participation part. So it would probably be like, I give you my workshop curriculum and motivate you that you do your own workshops based on that. And imagine you do a talk or workshops and suddenly a lot of people build on that and add their own ideas and do that. Then they participate. They become on your level and they do what you do. And I think that's a way to do communication. Thank you.
There's some time for questions.
It's not really a question, just a general thank you for your vision of how to do outreach that I adhere to. About no text in mathematical outreach, I think it's also interesting because we speak different languages all over the world, and I have always this problem. For example, now we are trying to translate some Russian book on mathematics to French, and there is always this big translation question of outreach material, which you don't have when you don't have text. So I don't know what you think about it.
We have a lot of text, and usually we have this, because the idea is you spark motivation, and then once they want, you have to give them the text in the right level. And a lot of mathematics is still communicated via text and via equations, and I think it should be this way. So we have the text, and sometimes it's just a LaTeX PDF somewhere that you can then download and read. There's no way around translations. And some of our exhibits are translated in 32 languages. You have to deal with it, and we build in all the exhibits, we build always this translation parts, so that it's easy for others to translate. So you cannot just, the international, the localization is super important. I think there's no way around it. I once started a project, it didn't work out, but this was really nice. The idea was to have a pool of freelancers and some money that we can translate. I think we also, with Image de Math, we translated some texts, but because there's the best article in French and nobody can read it, or you translate it once to Spanish and suddenly you have a lot of people, and you don't even have to rewrite it, but you have to, of course, translation is not easy, so I think there's no way around text. I don't know how we as a human race are changing in terms of what is our input. I still think there's no other way to really understand mathematics than having this kind of text part. It might change. Maybe there's more interactive visual mathematics in the future, but it's still super important, and you have to prepare this still. But the people would not read them right away. You have to get them first to read.
So in your concept of open participation, real participation, what strikes me that there's still an initiator. So you start and you propose something. For me, that means you have the money power to do it in the first place. So if you want to make it really participative in a way, how does the initiative spring up somehow, and how do you organize it?
I would love, you can ask me how often I ask funding agency, can you distribute money to others, or can you give us money that we distribute it? Of course, then we would still have a certain power, but at least we distribute it to others so they can create. It's very difficult to get these type of fundings.
It's just let people be on your level, but then there is still a level up in terms of organization or money distribution. There is still kind of one tiny level up, even if we try to open.
But at one point you could say that at least it's money that then can be used as a starter. For example, in Uruguay they added a lot of exhibits and they got their own local funding, which was quite good, and they had their own team. But it's also still this kind of strange world between it comes from Germany, it's cool, it's in New York, it's nice, so and it's this kind of, it has to go out, and that's also something we have to change. Like it's we're working a lot on the African continent, so of course the idea, I'm also talking to India that it's also like they should create their exhibits, and then we show the Congolese exhibit in Berlin in the Science Museum, and not the other way around. That would be cool, but it's it's difficult. And this whole money part, that's maybe another topic. The power is still not only knowledge, it's still funding.
I think it's also the responsibility of institutions that are using the material from Imaginary, that are making money out of it, to redistribute the money so that other institutions that have less money or less can make this kind.
Well, it has to ripple down somehow. I mean, if you're using some material from Imaginary and it has a huge success, then the next thing you create, well, first you try to create something that you give back as well.
Yeah.
Sometimes it's also just this kind of, we had a lot of mathematicians or universities, math departments doing exhibitions. They would not do an exhibition on their own, but suddenly they catch the flavor of doing an exhibition, so they do one. Maybe it's still copied, but then they know how to do an exhibition, and that's also interesting in terms of you transfer the content, but you also transfer in a way the knowledge, like on the meta level, how to communicate. It's not just the communication part itself, and that's also, the more people can do exhibitions, the more people will do exhibitions, and this will also spread and just help. Yeah.
Completely other direction. On your game fish.
Yeah.
Did you? Yeah, I love. Do you know if some marine biologists used your animation to create a mathematical model for behavior for marines, animals, or things like that?
Not in this example. I think this is just it's too simple, and I'm also not aware of any biologists using it for dissemination. But we have other tools, like the Surfer tool, for example, was used a lot in research, like to create papers, or to create, like, to, of course, to visualize their research papers, but also like in a way with this super fast visual feedback to stimulate new ideas. There are a few papers on knots, algebraic surfaces that look like knots, like Möbius strips or whatever, and that's so there's a lot of use, and that's also something that I like, that if you do something that ideally it can also be used in research or for research.
So you have some example for that?
Yeah, we have some examples and also some published papers, and now this latest project with the Future Mobility Simulator, that's also really interesting now, how this can go back into also politics, how they can decide about strategies for the future, even if it's just a simple simulation, but you can also make it more complex.
I have two questions about the interactives on touchscreen.
Yeah.
One is, are you never afraid about the addictive part of it? Because of course you want to engage people, but if they engage too much, especially young people, you can have some ugly parts.
The thing is, I'm a computer gamer, so I spent 4 or 5 years of my life when I was young playing computer games all the time. I think it was not too bad for me at one point. I think I have some social flaws on some sides, but that's why I'm probably not the wrong question to ask. My kids are still young. So far, they didn't play any computer games.
I was going to ask that. If your kids wanted to spend a few years playing computer games, would that be fine with you?
I don't know. But for me, it's like if I played, I cannot. I have to accompany them, in a way. Then I would play with them and try to select the good games. So far, we managed, and without putting a lot of effort, we don't have a TV, and there's no media consumption yet. They're 8 and 6. They don't know what is a TV. Of course, sometimes I think we have 20 minutes per week that they could watch, but it's so low that they forget sometimes. And I like that. And in the village we live, it's kind of, the education is not media centered, but it will come. Like the first neighbor kid, he wants to get a PlayStation now for Christmas. That will change the whole village in a way. It's a modern village. It's not like laid back, but it's probably the level where I don't know what will happen. I'm not afraid of addiction, because I think I don't know if it's the right addiction. It's also passion, So I don't know, but you have to accompany it.
You better be addicted to this then. I don't know, so third-person shooter thing.
Yeah.
Another question related to the interactive exhibits on touchscreen is about accessibility. You want to make an exhibition that is as open as possible, but this thing is kind of automatically excluding blind and less-sighted people. Yeah. And some of your exhibits have a physical counterpart, but many of them do not have.
That's something that we started now in the last years to work with more haptic interfaces and also audio interfaces, where we do a lot of. It's also, again, we are independent, and we are not governmental or university funded, so we can in a way only work for projects. And since we are non-profit, we cannot make profit and then fund our own research. That's a little bit of a problem. So, but the idea was to explore inclusion in terms of interfaces a lot more. That's why the talk about interfaces would be super interesting. We have one team member who is very much into it, and like the Lego exhibit is amazing. Also, how it feels. It's so much different. And now we really try to do different exhibits, and also going away from this kind of rectangular screen. So now we did a lot of it as projection, and it's like that the magic is put on other objects. But we still use the software part because that's so far our own way to be fast in terms of feedback. That's also interesting because everything else, even if this is super nice, it's not it's super nice, you know? But it's not real time. You know, it would be nice to have like a slider, and now I get it in real time changed. You know? And this still takes a couple of hours to produce, and that's it's a different quality of thing. But the interfaces, and like just right now we're doing also for the International Day of Mathematics, the next year's theme is Mathematics for Everywhere. We're just doing a big research on outreach projects connecting to Aurélien also for groups that are not in touch with mathematics. So it's really interesting, that project like Mathematics in Prisons, Mathematics for Senior People, Mathematics for Blind People. There's a lot of, we're just collecting, we do a big research. We also asked many people to see who is communicating mathematics to this kind of neglected groups. And here, maybe concluding this also, I think it's also, that's also like a marketing question. How can you reach them? No? So that's super difficult, super. And that's independent from the content, you know? It's like how to get there. Independent from the format, where I think it's also the format has to be adapted. Maybe not a talk, maybe more like a game or something, or sports, or using things that they're into it.
It's interesting that compared to Aurélien, who was saying that it's interesting, it was maybe a problem to have people thinking that they have the thinking is as good as any scientific thinking, and so if they have to choose between two of them, they would even prefer their own. And how would you do if suddenly some people use your tools in order to promote something which is against your
values?
Yes.
No, that's a thing. Like if there's a right-wing party putting an algebraic surface as a logo, I probably cannot do anything because it's like it's the tool. There's the license.
Which kind of party?
A right-wing party, I would say. Right-wing party. I would not be happy, or I don't know, if one of these big Nestle companies does mathematics communication, I would also have a problem. But that's my personal problem. I don't know if from the non-profit point of view, but that's what I say. People look at the one fear, like what do you do if? Ask me in the last 15 years, did you have a case like this? If you asked me this to me, I would say no. There was maybe some exhibition where I would say, okay, that's not the way I would do it, if like print a paper and put it with some scotch on the wall and make a math exhibition that they did in some countries. I would say, no, I don't like this, but it's still a math exhibition and it's still a nice image. And but that was never the case. And then you can ask me how many cases you have like you were positively surprised, and I can tell you tons of examples where they improved and had new ideas. And so it's really it's people look always at the bad part, which is for me didn't even happen, and they don't look at the positive part. But that's also something that we. That's why I was discussing a lot with science museums, and why don't they open up their exhibits, and this kind of losing control. People are really afraid of losing control, and they think that they are the experts. They think that they lose their expertness if they give out, and that's also, I think that's a problem in terms of a general problem, a human problem.
Kind of like that, but a bit less doomsday. Do you have any sort of intermediate resources, or say someone looks at your Navier-Stokes, which is really cool, and I feel like as mathematicians we look at that and we start thinking about ways that we can change it, we project our maths onto it, but there are plenty of people that would look at it and go, ooh, swirly colours. How do you get them? So after they're participating now because they're like, cool, I can do this. Yeah. But there's a difference between participation and engagement. So how do you get them from interacting with the tool and thinking this is really cool to then understanding things that mathematicians don't even understand? How do you get them there?
I mean, one thing is that, like in the actual exhibit, there is at least an equation there. So, and we would still not understand it. It's like decoration, So, but still, I mean, like you see, okay, there is a wind speed. Here I have gravity, whatever. It's several equations, and it's not something that you can really easily explain. But at least in your mind, you have, I don't know. Sometimes equations can also be art, how they're put. So you have a decoration and then you connect it to mathematics. I'm not afraid.
There's a bridge though, there's an in-between. Do you ever make people a kind of roadmap? Like, oh cool, you've enjoyed interacting with this. Here's the maths behind it, so you show them the maths. There's a journey that you need to go on now. Do you ever lay that out?
No, the roadmap is like our classical way is we have an exhibition and we have trained explainers. And the roadmap is the explainers. The explainers are there and they see, okay, this is like, I don't know, university professor or this is a young kid, and then they would adapt this. So this is my grandmother, and then look, here I have an online course for you. Here I show you the open questions in research, or look at this, you can play with this. There are 3 directions in space. Whatever level of the level goes always deeper. There's no end, and nobody knows everything. And so maybe the approach would also not be the roadmap, because this means that I would know what's good, but it's like this joint exploration. And let's look at your question, and I add a couple of questions more.
I didn't do anything.
But engagement as another noun would also be interesting. It's interesting because in German we use it in a different way. So for me, it's also it's different. Engagement is, what is the difference between engagement and it's more like passion in German, engagement, and not that much participation, or where would engagement be between interaction and participation? Or
as someone who's taught teenagers, they can participate in a class and very much not engage in it. They can do bare minimum and not take it to heart. So
okay, so this would be, engage would be really that I connect in a way. Yeah.
How many persons participate to this program?
We are 8 employees, not all of them full-time, and then we have a lot of freelancers around, and then all these things that you have seen are collaborations. Like the Navier-Stokes, for example, that's also an open source project which was there that we adapted. So we usually work with researchers on site. Some things we create on our own, so we have a software team where we do it from scratch, but generally it's always a collaboration.
May I add something to the question?
Yeah.
How many contributors do you have on your platform, on Imaginary.org?
On the platform itself, and actually,
for example, for this equation, who gives you this equation and explain you how to do it?
Pavel Dobryakov. So he did the WebGL fluid simulations. We added the parameters, the selections. Now we are working on a version which is connecting to sound on a different exhibit also, where the sound produces the fluids. But that's extras. But the core programming, also the WebGL fluid simulation, was done by Pavel, for example. And actually, what I wanted to do, I didn't have time today in the morning, like list all the names of all the exhibits that I have shown today, because that's also part of the game, that you always show the authors. I have to apologize that I didn't have the time. I put it wherever it's like crucial there, but there are many people.
Second question, do you have statistics of the impact of using each of these programs?
No, we don't.
You don't know how many persons explored these or these programs?
No, because most of it is also, we still believe in this kind of real human physical interaction. So we have installations in 17 mathematics and science museums, for example. I have no idea. We would have to ask Cindy or the other museums who are using exhibits with our content how well it works or how many people are going there. On the website, I have statistics how many people download certain programs. And then it's kind of this feeling where you see how many people are using these algebraic surfaces and create things that you would know. How many exhibitions are they doing? Usually, not all of them, but usually they would at one point would tell you, see, I did an exhibition, or they ask a question. So, but it's not properly evaluated.
Sorry, I have other questions.
Yeah.
for the persons use your program in your platform, okay?
Yeah.
how many persons simultaneously have you, what is the big number of persons simultaneously use it? And is there many countries using these programs?
So the thing is, it's really interesting because we are just re-evaluating the whole, I can show you here, users. So everybody can create an account and you can upload your own stuff. So and there you can see different. Here you see the user when they since when they're online, when they logged in last time, and what did they upload. And I think there, I don't know if this is the oldest, 148 times, I don't know, let's say 50 people using the website or registered. And then, but some people they're just registered, they don't do anything. Other people here they upload things. Some things would be an image or like a physical exhibit, I don't know, here, Alba, for example. So you logged in on October 17th.
These things are live on Imaginary.
And the idea here is that we have these categories and then you can go to, I don't know, to hands-on. I think that, and then you see, we uploaded here the board game, for example, you can just print it yourself or you have 2D prints, all types of, I don't know. These are more the physical games and then you would have, what's interesting is also this is like the exhibition proof content, and if you click on user, you have content from all types of people here. I think they uploaded in the wrong section, no? So this should not be a physical exhibit, but here you have a lot of other content, or the same with the software program. So whatever is tested, shown and evaluated is in the exhibition content, and everybody can just upload things. There are really some cool things in there that you can just, I don't know. Please remind me of what. Hyperwork, yeah. Some games or, and sometimes it's everything has to be openly licensed, but then it links to their own GitHub or websites.
I think I'll stop the questions here and then move on. So just let's thank Andreas and everyone again.